Alright, so quadratic applications. We're looking for the area of the walkway, and we're looking for the area and the dimensions of the garden. Definitely start out with a picture. Alright, if you could draw yourselves a picture, I think that will be very helpful. So we have Mary's, what kind of garden? Rectangular, right? So she has a rectangular garden, and it gives us the 6 feet. It says the garden is 6 feet more, the length is 6 feet more than the width. How big is the width? We don't know the width. The width is going to be x. How big is the length? 6 plus x, or x plus 6. Then we have a walkway that surrounds the garden. How big is this walkway? A walkway with 3 feet surrounds the garden. So 3 feet here, 3 feet here, 3 feet here, 3 feet here. So all around 3 feet. The total area of the walkway, so just the walkway, so this area here, is 288 square feet. Forget about the numbers for a second in general, okay? Forget about the x plus 6. How would I find the area of the walkway? What would you do to find the area of the walkway?
You add you subtract the middle, like the garden from the whole.
Very good. So you take the area of the, I'm just going to put big rectangle, subtract the area of the small rectangle, which is the garden, and that's going to give me the area of the walkway. All right, so in general, what happens? All right, so what do I need? I need the area of the big rectangle. So what is the? So I need a length and a width here. What is the length of this big rectangle here? X plus. X plus. I have what? What do I have from here to here? X plus 6, and then what do I have here? And what do I have here? So x plus 12. So my length here is x plus 12. What about my width? What is my width there? All right, so now I got my length, x plus 12, and now what's my width from here to here? X plus 6. So I have x plus another 3 plus another 3. I got my x plus 6. There's the area of the big, so I'm going to put that one down here. So x plus 12 times the quantity x plus 6. That's the area of the big one. Minus, what's the area of the rectangle, of the garden? X times x plus 6. Good. X times x plus 6. And once I subtract these two, what am I going to get? Once I subtract the smaller rectangle from the area of the... That's given, right? 288. That would be the area of the walkway, which is given. All right, so now we have our equations. Now let's solve. Let's FOIL this out. Combine like terms where we can. So if we FOIL this out, x plus 12 times quantity x plus 6, we should get x squared plus 18x plus 72 minus x squared minus 6x equals 288. All right, so that's just your FOILing. Distributed on my first one, distributed on the second one, equals 288. Combine like terms. I have x squared and minus x squared.
You forgot the plus on 18x plus 72.
Plus 72, thank you. My x squares go away, so I have 18x plus 72 minus 6x equals 288. Can I combine like terms again? Okay. 18x plus minus 6x. 12x plus 72 equals 288. Two-step equation. Solve this through. 12x equals what? 216. Very nice. Divide through by 12. X equals 18. So I have my x equals 18. So my length or my width of this is 18. And what's my length? And 24. So my dimensions of my garden are 24, and my width is 18. So here in this question, we're looking to determine how long it'll take the rock to reach the bottom of the canyon. Okay, so let's think about what this looks like, a visual. Okay, we're on a cliff here. That's 1,750 feet. The rock is thrown, downward velocity, and I'm looking for when this rock hits the bottom. So what is the question asking for? What am I looking for? Yeah, I'm looking for the x-intercept, okay? So what means do we know of finding x-intercept? How do we find the zeros of a function? How do we find the x-intercept of the function, or roots, or zeros? Or how do we find this? One of 3 different ways we've learned. 1, quadratic formula. 2, completing the square. Or 3, just factoring out. Okay, so you can use any one of these. Okay, depending on what the problem looks like, choose. All right, so let's start with our formula that we have to know. Okay, so here's our formula: h of t equals -1/2 g t squared plus, I know in science right now you're using vi, t plus s. G, what's g? Gravity. Okay, there's 2 measurements for gravity we're going to use. Okay, well, first measurement is what you're already used to, 9.8 meters per second squared. Or gravity is going to equal 32 feet per second squared. Okay, depending on what the problem has in it, what's this problem dealing with? Meters or feet? So which one are we going to use? Meters. Okay, we're using 9.8. VI, what's that? Initial velocity, right? So that's common from science right now. And then my S is my speed, or this one's going to be your initial height. Okay. So let's plug into this. So h of t equals -1/2 times what? 9.8 t squared plus my initial velocity. What's my initial velocity? 4. What does it say before that? If a rock is thrown downward. So what's my initial velocity? -4. So -4 t plus your 1750, which is your initial height. Simplify this. H of t equals -1/2 times 9.8, which is what? So you get -4.9 t squared minus 4t plus 1750. Would you try to factor this? Would you try to complete the square? Would you use quadratic formula? What would you guys use? What would be your choice here? You have a calculator handy. What would you choose? I would quadratic sounds good. So x equals -b, or 4 plus or minus square root of -4 squared minus 4 times a times c all over 2 times a. So after plugging this in, you should have got an answer. You should have got a positive and a negative. The positive answer you would have got would have been roughly 18.5, and since we're talking about t time, so 18.5 seconds. The length of a rectangle is 3 more centimeters than the width. The area is 70 centimeters squared. Find the dimensions of the rectangle. So I got my rectangle here. The area of the length of the rectangle is 3 centimeters more than the width. What's the width? We don't know. We call it W. That's fine. The length is 3 more than the width. What's my width? W plus 3. Good. The area is 70. How do I find the area of a rectangle? Length times width. Substitute what we have. We know what area equals. We know what the length equals. We know what the width equals. So we got W times W plus 3 equals 70. So the product of the length and the width equals 70. Now what? Distribute. W times W, W squared, plus W times 3, 3W equals 70. Set this equal to 0. You can complete the square, or you can just factor. All right, I'm going to bring over my 70. W squared plus 3W equals, minus 70 equals 0. Do I have factors of 70 that give me 3? 10 and 10, perfect. W, W, 10, 7. Which one's positive, which one's negative? Negative 7, positive 10 equals 0. Nice. Solve these out. W minus 7 equals 0. W plus 10 equals 0. What's W on the first one?
7.
W equals 7. And W equals negative 10. Can I accept both answers? Why not? Why not? Why can't I have a negative?
can't have negative dimensions.
You can't have a negative length. You can't have a negative width. Okay. So your W equals negative 10 does not count in this one. So you got W equals 7. So my width is 7, and my length is 7 plus 3, and we got a length of 10. All right. Some of these you can do mentally, which is great, but make sure you're able to show the work behind it as well.